assembled and soldered the propellers on the bottom, and I cut the holes eventually to reduce the buoyancy. And my name is Savannah.
I'm Taryn, and I help build the buildings and paint them.
I'm Danny, and I cut the PVC pipe that surrounds the city.
I'm Chris, and I helped hack glue the buildings and set up the PVC pipes.
I'm Robin, and I help build the buildings.
So in these pictures, you can see us cutting out the styrofoam with X-Acto knives and then hack gluing them together to make the buildings.
So I worked with Peter, Ryan, and we were the electromechanics team. We had to connect the motors to the controller, but we made sure that the propellers were strong enough to pull the thing down to make it sing.
And I did the interviewing for our setbacks, so whenever there was a problem, I was the one who was asking questions and writing it down on the journal so that we could record it and put it on the PowerPoint.
The controller and hooked up the motors.
I'm Sarah, and I help to set up and place and work with the motors so that they will work in situation.
I'm Peter, and I help with I help a little bit with the wiring and also with waterproofing on the building so that the wiring can get in without damaging the batteries.
So you can see here, we're soldering the wires to the motors, and we're testing the propellers to see if they're strong enough or not.
Okay, I'm Nicole, and I was part of the software group. So what we wanted to do was to take two lights on top of these towers and flash them like antennae in a 1, 1, 2, 1, 2, 3 pattern for on and off. So we had to learn a new language of code called Basic Stamp, and we wrote over 200 lines of code in order to get the lights to do that, then on the computer. And then from the computer, we uploaded the code to a microcontroller. Oh. This is what we uploaded it to. You can see them flash. And now she'll tell you how we got the wiring.
For the wiring, we had to learn the parts of the control panel so we know which wires would go where. We also had to learn to use devices so that we can do two lights on one row. And we had to use a parallel circuit so that we could put the two lights on one wire. We also learned how to solder it so it can stay in the building without us having to hold it.
Okay, so in this picture, our helper, Mr. Bryan, was teaching us how to, because at first we didn't know how to do software programming and stuff like that. He taught us how to turn them on, turn them off, and how to keep them blinking. So high is on, low is off, and pause is how to tell us to keep them blinking. And we're going to show you a video of in the first day, we were trying to think of buoyancy, and how we were doing that was to build it out of PVC piping and foam, and we kept that because that worked great. And one of the second things we were thinking of was how to connect it with the other cities. And what you see here is an electromagnetic propelling system with a wire cable pulley system, but the advantages of that would be that the cluster of cities could expand and contract at will, but the disadvantage would be that the individual cities couldn't connect, or couldn't disconnect. So we decided against that, and instead we used an alternating magnet system on each sides of the hub.
During the design process, we came up with, there was a bunch of ideas. And the final that we had was there would be a main hub and there would be a triangle, and they'd all be different triangles on each side of the one main triangle. And our final idea would be one large square and 3 rectangles on the side, and that's the one we ended up choosing.
Alright, so then we decided that our city would be the shape of a triangle and that we would surround the city with PVC pipe because that would provide it with a good structure while also making it buoyant.
Our biggest problem with having our boat was that it could not sink at all. Like, it's so awful. So what we did was we went back to the drawing board and we got bigger engines and we cut off surface area so it wouldn't be so resistant in the water.
Video of our first trial.
So because there was so much surface area on it and we couldn't sink it, we had to make 3 holes in the triangle board to reduce surface area and let the water flow through. It helped a little bit, but it didn't fully submerge.
The surface area, so we decided to maybe try a stronger motor in hopes that it would help, and these little ones were not working.
So the boat still would not sink, so we tried switching to a bigger motor and a stronger motor to pull it down.
So for the third trial, it still didn't sink, so we decided to put a larger propeller on the motor so that it would sink.
So after that, we took it out to the lake, which is a little bit wavier, so we didn't know how the motors would handle it. But it ended up not being strong enough, so what we did was we increased the propeller size and increased the voltage from 3 volts to 9 volts.
So what I learned from the experience was that even though we didn't complete every single aspect of the challenge, like we never actually got it to sink, but we learned a lot along the way about how to wire things and how to at least try and make them sink. So I think that that made it worth it.
We also learned that coordinating teamwork in large groups of people like this is very hard, but it's also very helpful in the end.
Okay, so the music at the beginning was done by Zion. No, yeah, right there. Sketches were all done by Savannah. Savannah and I worked on the PowerPoint. Eric did all the interviews for our topics, and then pictures. And then we would like to thank all of our chaperones for helping us learn different things to help us with our project.
All right, everybody who loves engineering, smile.
That better be everybody.
Zion, say that got mixed feelings. They really do.